So this video will talk about the breakout board that we have, and I'll show you some pointers on how to manufacture one of these. Okay, so on the breakout board you'll see that there's some white screen print which tells you a lot of information. So for example, this is where the motor driver goes, the L298 motor driver, and it has D7 as an input, which is inputs 1 to 4 on the motor driver, D6 as an inputs to 2 and 3 on the motor driver, and D5 is enable. So D7 relates to the pin on the Arduino, which is an output pin which communicates to that motor driver. So we've got D7, D6 and D5. Those three pins are hardwired to this motor driver to then control the motor. You can also see that we've got two servo connectors here. So servo 1 and servo 2, and it says here D9 to servo 2, so pin D9 to servo goes to servo 2, and pin D8 goes to servo 1. The rest of the pins are connected to the power and the ground, so you don't need to do that. However, there is a mistake, I'm afraid, so apologies, it's the only mistake I've found on this circuit board. It's actually D8 is servo 2 and D9 is servo 1, so apologies for that. I have updated, put an update on the Learning Hub so you can see all of that. And basically this is a breakout board. It's a carrier for this one of these Arduinos, where you can see you've got your pins. So these are the D pins, so D7, D6, D5, the ones that I was talking about, and they are connected to the motor driver and the servo. And also the pins of the Arduino, so the analog pins, power pins and the digital pins are all taken out to these pins here, where you can connect screw terminals such as this one, which makes it easier for you to solder those in, and then easier for you to just put wires in and out, so it reduces the amount of soldering you have to do. Okay, so I'm going to give you some tips on how to make one of these boards up yourself. Most of the components will fit in quite easily. Now, to start off with, you want to connect the Arduino. So the Arduino needs to have the pins facing upwards like this to have onto the Arduino. So what I recommend you do is take these and put the long end into the Arduino carrier like that. So, and then you can just break that out like that, put one in there. This Arduino that I'm using is actually a non-functioning Arduino, so we're not too worried about breaking this one with the heat of the soldering iron. So what I'm doing is I'm just putting the pins in like so, and just breaking them. If you break them too short or too long, it's not a big problem. What you can do is just use some snippers, snip it if you like, or if there was one that was too short, then you can always just snip one off here and put it in. When you solder it all in, it'll all hold it into place. Okay, so you've now got the short ends sticking out like so. And what you can do is just put that into the circuit board as so. Make sure that the white screen print is upwards, and you've got your Arduino that way around, and then it's a case of soldering. So what you want to do is make sure that the pins are peeking through and they're all nice and level. Now, the way I like to solder is you get your soldering iron, make sure that it's clean, so I've just wiped it on the sponge, and then we call it wetting the bit like so. And what I suggest you do is you can just briefly put the bit and the solder on at the same time. And what I do is I put it at the four corners, so then you know, now that one's hiding behind the roll that I'm just holding it with, but it doesn't matter if it's not strictly the four corners, but then it's in position, it's not going to go anywhere. Then it's just a case of each individual pin is soldered up like so, and just checking, I'd already done that one, just checking that you're not short-circuiting anything. So make sure that in your solder there's none of the pins which are bridging over, because that would then make the Arduino not function properly. Okay, so we've just done the one side. May as well do the others. Just keep it in camera. Of course, it's always a good idea to have an extractor while you're doing this, because the fumes aren't great. However, I've kept the extractor off so it doesn't interfere with the sound of the video. But normally I would have an extractor on. Okay, so now we have our Arduino in place, and you can take your Arduino off. This one was just used as a placeholder, so it's in position. So when you get your working Arduino, you can plug it in and out. So you don't need the Arduino in there anymore. Okay, so this device has a motor driver. So the motor driver takes digital signals from the Arduino and allows a large DC motor up to 4 amps to be driven by the motor driver. So you can get yourself a motor driver, which is, this one is an L298, and you'll see that on one side it's got more pins than the other. So that nicely drops in. I always say try not to touch the pins if you can, because you can get static build-up. So put the motor driver pins in there. Try to make sure that it's upright, because we can screw a heatsink to it, because when it's used in anger it can get quite hot if it's driving that amount of current. Okay, so again, carefully, you might want to just do the 4 corner pins again, just to make sure that it stays in position. So this motor driver is actually an L298. You can have a look at the data sheet for it. If you Google L298 data sheet, and you'll see all about it. You'll see that it's a 2 amp motor driver, but what I've done with this circuit is I've doubled it up. So I've put 2 motor drivers into one. So actually it's 2 lots of 2 amps in parallel with each other. And what I'll do while I just remember is show you the schematic. Let me just solder that into position. Okay, that's looking okay. You want your solder joints to be nice and shiny. You don't want them to be not very shiny, or it just means that the heat wasn't right. So just make sure your soldering iron's nice and hot. So, and just ensure that there's nothing that's bridged over. Okay, well, so there you have your motor driver in place and the Arduino. So we're getting close to this being able to drive the output here. I'll come back to that in a moment. So what you will see on the Learning Hub is the printed circuit board, the schematic. So this is the schematic of the first bit that you design when you're making one of these printed circuit boards. And you can see that you've got your Arduino here, and you've got the pins A0, A1, A2, A3, A4, A5, the digital pins, D0, right through, and some of the power pins here. And you can see that these analog pins simply go to these things, which is the screw terminals. So they are that bit there. So that's what that represents. You'll see that, more interestingly, that some of the pins go to the motor driver. So we have our motor driver here, and we've got inputs 1, 2, 3, 4, and enable A and B. A and B are the 2 halves of the motor driver. And what you will see is that some of those pins are connected to the pins of the Arduino. And what I've just realized is that you can't see them on this, but I'll update this schematic so you can see it. You can actually see which ones they go to. But you'll see that on the updated schematic. I've just realized that's one where I didn't show them. Okay, the next step that you do is you have your printed circuit board and you lay it out like this. So that's the motor driver, the L298 motor driver. The Arduino is here, and then you've got your screw terminals here and here fused. So you just lay it out like this. You can then send that off to be printed, and then what you get is one of these. So this is a photograph of the system that's ready built up with all the components in. So that's how it's made up. Okay, so you have your motor driver and the sockets, and the next one I suggest that you do is put a power in. So you've got these here, these screw terminals, and what I suggest you do is, well, pretty imperative really, make sure that the open end is facing on the outside of the board in that way. So you can hold that in position. You might need a friend to make sure that it's held in the right place. I was quite lucky that it's been held down just right so I can see those bits. I'm just going to clean my soldering iron tip so it's nice and shiny and wet it. Okay, so that allows the flow, and then solder and solder nicely. Okay, so that's my power. And then I might want to make that drive a motor, but what I can also do is put a switch in. So the switches we have are these ones here. They're actually 3 position switches, on-off switches. It should just be 2 position really, but the ones that we got are just 3. It doesn't matter, you just go from one extreme to the other to switch on and off. And there's a little on symbol there. Now what we found with these switches is that the connectors here are just a bit too fat for the holes. So what you have to do, and we couldn't find any switches with smaller connectors, so what you have to do is just get a file and then just file them down a little bit, because you'll find that those legs don't fit in very nicely. So basically I'm just going along and filing, just about 10 or 20 should do it, and you'll see that those pins do get a bit narrower. You can always do the ends of the pins as well, like so, but give it a bit more. I'm just demonstrating now. So they should be changing colour slightly and slightly smaller, like so. Okay, so once you've got that, then that should just about fit in, like that. As long as you've got something to solder onto on the other side. And this switch is just for the main power, which will drive the motor. But also if the Arduino is disconnected from the computer, normally the Arduino is powered through the USB of the computer, but if it's disconnected, as in it's on the challenge strip and it won't have a computer connected to it, then that will also provide power to the Arduino, so on and off like that. Okay, so another bit you might want to use is the motor. So you can put a connector on there. And what I'm going to do to make sure that that connector is proud is just stand it on that reel so I can see the holes, making sure that the terminals are outside, the screw terminal bits are outside, and solder that in like so. Okay, so getting a bit closer. And then it might be, now you don't have to populate all of these with all of the digital input pins. In fact, you don't even have to put the screw terminals in if you don't want at all. You could solder the wires in directly. But for the sake of prototyping, it might just help you just to have some screw terminals in. Like I say, you don't have to completely populate it. You can either populate them with 4s, like this one, or 2 2s, just depends on what's available. Okay, so let me say, for example, that I want to use the pins D4, D5, and D6 and D7. What I'm actually bearing in mind is that with the motor driver, they are hardwired to D7, D6 and D5 for that motor driver. So those wires which go into the motor driver are also replicated here as well. So you don't want to use those pins for anything else. So if you want to connect another sensor, then it's wise to choose pins that aren't D5, D6 and D7. So those 3 pins are actually used with the motor driver, and I have got a reminder there as well. So if you wanted to use other pins, it might be a good idea just to use maybe D8, D9, D10 and D11. If you wanted to do some other pulse width modulation, there are some little tilde signs which show you which pins are available for pulse width modulation. Okay, so what I'm going to do is just solder this one here, like so. So that's the digital. I might need some analog input pins, and in that case I can put some analog input connectors into my A0, A1, A2, and so on. Okay, so that's soldered in. So if I wanted the analogs, then I've got my analogs along here. Power, ground, 3 volts and 5 volts. I've got those there. If I wanted some in there, I can do. If I wanted to use the servo motors, then, for example, the steer servo motor, then I would need 3 pins on there. So what I can do is take a strip of this, and with the snippers just cut off 3. Okay, and put that into, I'll put 2 here just in case you wanted to use 2 servo motors, but it just helps with the flexibility. You might not use 2 servo motors. And then this is the tricky bit, is turning it over and then making sure it stays in place and soldering it. Now, one trick you can do is to use blue tack. So blue tack can be on the side of the board, keeps it in place. Just remember, if you have got a friend to hold the other side, that the pins do get very hot when you're soldering them. Okay, so that's a servo motor interface. Now, I think I mentioned this earlier before, this servo motor is servo number 1. Here it says D8 is servo 1, it's not actually, it's D9, and that's updated. So pin D9, which is a digital pin from the Arduino, and it's also shared with these, so remember that D9 here is connected as well to this servo. Now, it might be that you're not using this servo, so it doesn't matter, you can easily use D9 and you're not using it for anything else. That's fine, it doesn't make any difference, it's just a piece of wiring for you. Okay, so you don't have to do anything else to make a servo motor move, except for give it power, switch the switch on, and give it the correct pulses. In this case, servo 1, it will be the correct pulses in D9, which I'll cover in the lecture. To make the motor move, we have to do a couple more bits. We have to put a fuse in here, so you'll be given a fuse holder, and then you can snip your fuse in. I'd recommend 5 amps because the motor driver is a 4 amp motor driver. 5 amps gives it a 1 amp leeway for stopping and starting and slide when it's stalled. And I also recommend that you put 4 diodes in as well. Those 4 diodes will stop back EMF, back electromotive force, which can damage the motor driver after a bit of use. So there's a little line here which shows you which direction the diodes should point in, so they're all pointing to the left here. You can also put in a heat sink, which I recommend. You screw a heat sink to the motor driver because it can get hot. You can put a small capacitor in here, which is known as a decoupling capacitor, which can just reduce any effects of noise, of electrical noise when you're driving a motor. There are other items. You can put an LED if you want. It's quite handy to have an indicator LED. That's connected to pin D13 of the Arduino. Make sure that you've got the flat end of the LED, and it's shown here on the silk screen that it works the right way around. And you'll also need a current limiting resistor. I recommend 180 ohms, and I've put that on the silk screen as well. You might want to use I²C, which is something we'll talk about in the lecture. So here you've got the pins SDA and SCL. So again, you would just use one of these connectors if you like, or solder it directly in. It's entirely up to you. If you're using the I²C, then you also need to have some pull-up resistors, 1K and 1K, and I've put the spaces for them here. So I think that's all you need to know to get your circuit board up and running. So here's one I made earlier. I've got the diodes in place, the fuse in place as well, and a photo is on the hub. I haven't got the switch in there. So your power goes in here, 7.5 volts in, plus and minus. And there you go.